In this video, we're going to look at the questions about Aqua Regia. It says Aqua Regia is a mixture of nitric acid and hydrochloric acid is used to dissolve gold. The gold can be recovered by reacting the tetrachloroaurate ion with sulfur dioxide. So they give the unbalanced reaction of gold and Aqua Regia, and then they give the unbalanced reaction of tetrachloroaurate ion with sulfur dioxide to recover the gold. So these are two different redox reactions. The first question says, which chemicals are the oxidizing agent and reducing agent in the reaction of gold and Aqua Regia? So anytime you're running into a question where they're asking what's the oxidizing agent or reducing agent, or is this a redox reaction or not, you can always reference back to the oxidation numbers. If the oxidation numbers change, then it's redox, and you'll be able to tell what's gaining electrons and losing electrons. So here, I've already assigned the oxidation numbers. If you do not know how to do that, you need to go back and revisit that. Gold is an element, so it's 0. Nitrate ion has 3 negative 2s, and it comes out with a net negative 1, so it's a positive 5. The gold is going from 0 to plus 3, so it's losing electrons, it's oxidizing, it's the reducing agent. And the nitrogen is going from a plus 5 to a plus 4, and so that's the gain of electrons reduction. It's my oxidizing agent. So gold is my reducing agent, and the nitrogen in nitrate is my reducing, or my oxidizing agent here. Sorry, oxidizing agent, reducing agent. You can see that my gold is going from 0 to plus 3, and so in the next question it says, balance the reaction of gold and Aqua Regia. How many moles of electrons are transferred in this reaction? So I have 0 going to plus 3, that's 3 electrons per gold. It's going to look redundant, I write it a second time because this is just one gold. Here, I've got going from plus 5 to plus 4, I get 1 electron per nitrogen. This has 1 nitrogen, so it's 1 electron per nitrate ion. Now this is going to allow me to balance my electrons, which then allows me to balance all the other atoms. Here I've got 3 and 1, the lowest common multiple is 3. So I'll put a coefficient of 1 here and 1 here. And here, I'm going to have to multiply by 3 to get 3 electrons gained and lost. So I get 3 of those and 3 of those. So my golds and nitrogens are now balanced. My chlorines are not, so I'd probably better do that. I've got 4 chlorines here, so I'll put 4 chlorines there. Now all of the atoms are balanced except for oxygen and hydrogen. This side has 3 times 3, so it has 9 oxygen, and this side has 6 oxygen. So I'm going to add waters to balance my oxygen, and so I'm going to add 3 waters, and that now gives me 6 hydrogens on this side, and I don't have any hydrogens on this side. It's an acidic solution, so I can add hydrogens to balance it out. I get 6 hydrogens, and now I've done everything I can to balance, other than maybe checking. So 1 gold, 1 gold, 4 chlorines, 4 chlorines, 3 nitrogen, 3 nitrogen. 9 oxygen, 6 plus 3 is 9 oxygen, and then I have 6 hydrogen, 6 hydrogen. This side has a 6 positive and 3 negatives and 4 more negatives. So this side has 7 negatives and 1 positive. It has a negative 1. This side has a negative 1. It is now balanced. The next question says, which chemicals are the oxidizing agent and reducing agent in the reaction of tetrachloroaurate ion and sulfur dioxide? So it's asking the same thing about this reaction. And then it says, balance the reaction, how many mole of electrons are transferred in this reaction? So I've assigned the oxidation numbers here. Again, I have my gold going from positive 3 to 0, so that's the gain of electrons reduction, that's my oxidizing agent, and sulfur is going from plus 4 to plus 6, so that's losing electrons, oxidizing, that's my reducing agent. 3 to 0 is 3 electrons per gold. That's 3 electrons per the ion, tetrachloroaurate. And here we've got 4 electrons to 6, so that's 2 electrons per sulfur, 2 electrons per the sulfur dioxide. So my lowest common multiple is going to be 6, so I can answer the moles of electrons transferred. It said how many mole of electrons are transferred, 6 mole of electrons are being gained, and 6 mole of electrons are being lost. So this is a 2, I need 2 golds, I need 3 sulfurs, and 3 sulfurs. I've got 4 chlorines, so I'll put 4 chlorines here. Now I balance my oxygens. I've got 6 oxygens here, and I've got 12 oxygens here. So I'm going to add 6 waters to this side, and then it's going to be similar arrangement. I'm going to need 12 hydrogens on this side to balance out my waters. So if everything worked out, then I should be able to check my charge. I have 2 negatives on this side, and I've got 6 negative, and 4 more is 10 negatives. Right, so I've got 6 and 4 more is 10 negatives, and 12 hydrogens is 2 positive on this side, and I've got 2 negatives on this side. So I've made a mistake here. Where is my mistake? I've got, oh, here's my problem. I had not 4 chlorides, but I have 8 chlorides. So I've got 8 chlorides and 6 negatives. So that's going to give me my 14 negatives and 12 positives. I get 2 negative on this side and 2 negative on this side. So it does balance out. The negatives allowed me to detect, or the charge allowed me to figure out that I'd made a mistake. Oxidizing agent and reducing agent identified. We can see the gold tetrachloroaurate is being reduced, and the sulfur is being oxidized. Hopefully that helps you figure this out.